Hello once again, YouTubers. So we're here for physical science once again. I'm still covering our lessons on organic chemistry. And so what I thought I'd do on this session is I just want us to look at past exam question of 2020, November 2020. In particular, the application of organic chemistry. So if you haven't hit the subscribe button, please do so that you can see more of our lessons. And then if you need to get in touch with me, or if you have any questions from any previous past papers or something that you'd like for me to cover, please just email me, mlungisi.m.nkosi@gmail.com. That's Mlungisi, my name, .m for Mary, .nkosi, my surname, @gmail.com. All right, let's get into it. So I've got the November 2020 paper with me, in particular the application on organic chemistry. So what I want us to do is just to go through question 2 together, and then we'll go through all the other questions as time goes. But for now, I just want us to see how we're going to apply that organic chemistry. All right, so there we have it. Okay, so they give us compounds A to E rather. They say the letters A to E in the diagram, in the table rather below, represent 5 organic compounds. Okay, so let's just check. So first of all, you've got compound number 1 there. Can you see that compound? It has, okay, I see I've got side chains there. There's my parent chain, and I've got a halogen. So that should be a haloalkane, right? And then I've got compound B, C3H8 with an O. So they've written that down in what we call a molecular formula, right? So we're going to see what compound that is. It has 1 oxygen. So there's actually 3 possibilities if it has 1 oxygen. So it's either an alcohol, right, an aldehyde, or even a ketone, right? So in that case, we'll see which one it belongs to. And then compound C, okay, I don't know if you can see that clearly. So you've got that's definitely an ester there. You've got that O that's in line with our carbons, and you've got a double bond O there. And then they say you've got pentane 2-one. Okay, so that should be a ketone. And then the last one, compound E, that's 4-methyl pent 2-ine. Okay, so we're going to look at the questions that follow. All right, let's go through it together. So they say compound D. So use the information in the table rather for the questions. They say for compound D, write down the homologous series to which it belongs. So compound D, that's pentane 2-one, right? So which homologous series does it belong? Of course, it belongs to ketones, right? So that's 2.1.1. Let me write it down there. Okay, so that should be, so ketones. Okay, so that's what it belongs to, right? And then they say they write down the IUPAC name of a functional isomer, right? So compound D has got a functional isomers. Now, please, I want you to note, remember, we said in our previous videos, right, that functional isomers, these are organic compounds with the same molecular formula, right, but different functional groups, or you can say they belong to 2 different homologous series, right? So now keep in mind, ketones are functional isomers with aldehydes, right? They have the same molecular formula, but the structure is different, and in particular, it's the functional group that's different. And then the other ones that are functional isomers of each other are esters, as well as so esters and carboxylic acids are also functional isomers, right? So in this case, we've got pentane 2-one, right? So we know that the functional isomers of ketones are aldehydes, right? So it means that the IUPAC name of the functional isomer should be pent, so that's penta, right? So that it should have 5. And then al, that simply tells us it's got that C double bond O with an H at the end. Okay, so the functional isomer is pentanal. Okay, you can use that. You can use a capital letter P there if you want to. Okay, right, and then let's go to the second one, to the next question. 2.2.1. Now they go to compound A. IUPAC name of compound A. Right, you're going to help me with that, right? Okay, so looking at compound A, let's see which one is the longest chain. We want the longest carbon chain, right? So that's 1, 2, 3, 4, 5, 6. Is that the longest? Yes. Doesn't matter which way I go. Right, now the first thing that we said, we're going to need to give a number, right? We need to give an address. So in this case, I'm going to say rather, let's give a number, all right, from the side. We said we need to give a number from the side that's closest to our functional group, right? So which one is our functional group this time? It's going to be definitely the bromide ion, right? There, that's the halogen because it is a haloalkane, so that's the functional group. And can you see, it's going to be closer from the right hand side, so I'm going to number from the right hand side. Okay, right, so I'm going to say this is carbon number, in fact, you know what, let me just quickly redraw it. I'm not going to put in the hydrogen so that it's easier for us. So we've got CH3 there, that's a side chain. We have a CH3 there, that's a side chain, and then skip 1, and then we've got a bromide there. Okay, right, so how are we going to name this? I'm going to number from right to left, so that's 1, 2, 3, 4, 5, and 6, right? Why? Because it was closer to this side. Okay, so now remember, we said first of all we identify our parent chain, isn't it? Okay, the longest chain, that's our parent chain, so it's got 6 carbons, so that we are going to deal with last. Okay, so now we've got a bromo and we've got methyl. We said you take letters of the alphabet, isn't it? So we're going to say this is 2-bromo, that's 2-bromo. Okay, and note you've got 2 of the same things at 4 and 5, so that's 4, 5. Notice it's a comma there. Di, remember when we've got 2 of the same thing, that's dimethyl. Okay, and then the last part, it's all single bonds. Okay, it's 6 carbons, so this is going to be hexane. Okay, right, just as simple as that. Sorry, I couldn't fit it over there, so that's why I wrote it there. You try and make it one name, right? Okay, awesome. And then the next question, they say write down the structural formula, okay, of compound E. All right, so they gave you a name, the IUPAC name, and they want the structural formula of it. Okay, so let's try and see how we get from name to structural formula. Okay, so we start, so I usually say remember, you remember that this was the parent chain, but we named it last. So I normally say just start at the end there. Okay, so that's pent, so it means that our parent chain has got 5 carbons, and at carbon number 2 there's an ion. So let's start with the 5 carbons. So that's 1, 2, 3, 4, and 5, right? And at carbon number 2 I've got an ion, YNE, so that's a triple bond. Okay, so I'm going to do that there, and it's telling me that at carbon number 4 I've got a methyl. So 1, 2, 3, 4. So over there, I've got a methyl. That's a CH3 group there. Okay. Oh, and by the way, they did say in structural formula, right? So maybe you want to expand that a little bit. All right. So we just need to make sure that the number of hydrogens is the correct number. Okay. So look at that quickly. So that's okay. So that's 4 methyl. 1, 2. Okay. Pent 2 ion. Remember, between carbon number 2 and 3, we take the smaller number. So it's got a triple bond there. Okay. And yeah, there it is. So 4 methyl. Okay. And we've got pent 2 ion. All right. Next question. All right. Now we go on to question 2.3. All right. Okay, they tell us that compound B is a primary alcohol, right? So they say write down the meaning of the term primary alcohol. Now, just remember, ladies and gents, that primary alcohol, just by definition, we say it's an alcohol rather that has the hydroxyl group. Okay, so hydroxyl is the OH. Okay, is only attached. So if I've got an OH there, is only attached to one other carbon atom with its hydrogens, right? So it's only attached to, or sometimes they just say it's a functional. It's an alcohol that has the hydroxyl ion, okay, group at the terminal carbon or the carbon at the end, right? So usually the carbon there is the carbon at the end, sometimes referred to as the primary carbon. All right, so that's the definition there. And then they now tell us compound B. So it's this guy here. Okay, you remember we said we didn't know what this guy is, right? Well, I kind of know, but of course I didn't want to give that away. Right, so they say to you, write down the type. Okay, sorry, I skipped something there. They say compound B reacts with another organic compound X, all right, to form compound C. Now, hold on, ladies and gents. Compound C is an ester. Can you see that? Okay. And I said to you, every time you look at esters, all right, I want us to do that together, okay? So, esters are made out of two things, right? So, first of all, we know that esters are made out of alcohols as well as carboxylic acids. So, what you do with an ester is that you first of all check where is my, they call it the cleavage O, right? And cleavage just simply means it's a division between two things. Please, for those of you who think it's derogatory, right? So in this case, you look at this. So there's our O there, our oxygen that's in line with our carbons. So it's now separating between two parts, the alcohol part as well as the carboxylic acid part. Now we said, look at this. That's the carboxylic acid part. Why? Because it has the double bond O, and then so meaning that must be the alcohol part, right? So the alcohol must have had 3 carbons. It must have been a primary alcohol, right, with 3 carbons and an OH at the end, right? And then the carboxylic acid must have had 4 carbons with a C double bond O with an OH at the end. Can you see that? Right, now they say to you, compound B, so think about it. It's two things that reacted. It's an alcohol and a carboxylic acid. And you know, carboxylic acid has 2 oxygens, so that couldn't have been the carboxylic acid. So, of course, what does it have to be? It definitely was an alcohol. Can you see that? right? So they said compound B reacted with another compound X. So it means they're saying compound B, and you can see we've got 3 carbons there, and compound B also has 3 carbons. Okay. Yeah, sorry if it doesn't show very clearly there. Right, so in this case, this must be the alcohol that formed, and then obviously compound X, therefore, must be the carboxylic acid. Okay, right, now they say name the type of reaction that takes place. Remember who you are, Simba. Okay, right, so that's going to be esterification. So the formation of esters is through a condensation reaction called esterification. Okay, right, and then they say give the IUPAC name of compound X, right? So compound X should have been the carboxylic acid, okay, that reacted to form this ester. And in this case, what is that carboxylic acid? It must have 4 carbons, so that's going to be butanoic acid. All right. By the way, just to show them, man, we know our stuff. Okay. Right. So, how do we name that ester? Remember, you start on the alcohol side. Okay. I know that's not part of the question. So, how do I name that ester? Remember, we said that O separates, right? Okay. So the alcohol side is the one that doesn't have the double bond O. You start with that side. So this is going to be propyl. Okay, so this is propyl, and then you go to the carboxylic acid side with the double bond O. That's butanoate. Remember, esters have got that suffix of NO8 at the end. Okay, or O8 at the end. Okay, so I'm leaving it there. That's November 2020. That's question 2. I hope you got the best of it. Bye bye.